All right, what I'm doing is the 3 different types of optical telescopes. There's many other types of telescopes. You got infrared, radio, ultraviolet, and the ones most of y'all are going to use are going to be optical telescopes. The most common, and probably the most iconic kind, is the refractor. This is a refractor telescope. It's simply a tube with a lens at one end and an eyepiece at the other. The whole job of the lens is to focus the light down to a point here so that the eyepiece can then magnify it and send it to your eye. Like I said, it's a private telescope you've seen hundreds of times. Very common, very easy to make in small sizes. Like I said, that's the pros. The cons are, once you get above about 6 inches, the prices, because of the lenses, at larger 6 inches, start getting expensive. You start getting really, it's really hard to make a scope, a refractor, above 6 inches that's cheap, because you start getting into above 6 inches, thousands to tens of thousands of dollars for a scope in that range. And to solve that, Sir Isaac Newton invented the Newtonian reflector. Very simple design, a tube with a mirror in the very back of it that bounces and focuses the light on a mirror in the front, and then that in turn focuses and bounces the light out to the eyepiece. The advantages are mirrors are cheap, easy to make. You can have large mirrors for the tenth of cost. Like that 10 inch like that can $400 or $500. Whereas, like I said, the 10 inch in that, you're in the tens of thousands of dollar range. The catch though is, as you increase magnification of the scope, they tend to get bigger, longer, and no difference for this one. We'll get into that here in a minute. Let's see. And then we come to the hybrid, which catadioptric scope, which this right here is a type of. I say that this particular catadioptric is a hybrid because right in here there's a lens that focuses or corrects the light coming in for a mirror in the back, which then reflects off to focus and reflects the light from the mirror in front, and then that's the back of the scope. The advantages of a catadioptric telescope is, alright, you look at this one. This telescope it's hard to see, but right here it's 700 millimeter focal length, which means the light coming from the back of the lens to here is a maximum of 700 millimeters. This one's 300 millimeters. This one's 1500 millimeters, roughly more than double this. But you look how small this scope is, it's only that big. That's the advantages of the catadioptric, where it bends the light inside itself, so that way you can have a long path of light in a short distance.
And the black thing on the end is just to keep the light out, extra light out?
It keeps the dew off of it.
There you go.
Yeah, it's a dew shield. Of course, I didn't put that out here.
Got a question.
The advantage of this is that, much like the Newtonian reflector, mirrors are cheap. These can get huge and not be that expensive, relatively speaking. All right, let's go to the basic parts of a scope. Of course, we mentioned lenses and mirrors. Well, then you've got your focuser, your eyepiece mount, your actual telescope tube, your telescope mount, in its various forms. Of course, I don't have one out, but you have a star finder that helps you locate stars in the sky. Goes up there. Because when you're aiming a telescope, you're looking through just the eyepiece. It's like trying to aim and find something with a straw in the sky. It can be done, it's just not easy. What the Starfinder job is, it shows you a nice wide swath of the sky, and you either put a dot, or put a circle, or a crosshair on it, and then you can find it in the eyepiece. Now, unfortunately for us, about all the telescopes we got on the field tonight are of the alt-azimuth type. We don't have an example of the equatorium type. The advantage of the alt-azimuth is it's very simple. All alt-azimuth scopes work in a up, down, left, right motion. You'll track something, you follow it up and over, up and over, and up and over, and then as it goes down, down and over. The problem with that is, there's two problems. One is, it's not a smooth fluid motion, so you get some jerkiness. Sometimes the object moves in and out of the field of view. And the other problem is, with an alt-az mount, as the object goes across the sky, it appears to flip. So, you know, like Orion, he starts off the night standing up, he flips the night on his head. I mean, in the morning he's on his head. It's just, talking about equatorial mount. Equatorial mounts allow you to line the mount up with the celestial pole, or Polaris for loose terms. And what that allows you to do is it more naturally tracks the path of the stars. Stars aren't moving where it's moving, but you know, from our perspective, it tracks the path of the stars across the sky in one fluid motion. So you don't have the jaggedness and you know, it's just one thing that you have to turn. And this right here is a fully computer-controlled telescope. Once it's aligned, I can tell it what I want to go to, and it'll find it, put it in eyepiece, hopefully. And these are, of course, manual. Now, of course, the sun's in the clouds, so I can't show you the sun. But I'm going to do a little bit of safety when viewing. You can look at the sun with a telescope, but you have just do it safely. You have to have a solar filter that goes over the front of the telescope. The job of that solar filter is, this particular filter, for example, blocks 99.999% of the light. And if the sun was out, it's still a real bright image. The reason you have to do that is, and the best example I can give of is on YouTube. There's a video, an instructor at a museum has some students out, and he's showing them the telescope, and he's showing them the sun. But what he does before he shows them, he shows them how dangerous it is. He lays a grape on the ground, points the scope at the sun and at the grape, and vaporizes it. So without a solar filter, that would be your eye. Another point of safety is some scopes come with solar filters that go in the eyepiece. It's a big no-no. When you focus sunlight onto a surface like that, it's strong enough. It can melt glass, it can melt metal, it can definitely melt plastic. And with that little piece of glass, which usually they're glass mounted in a plastic frame, it's going to melt. It's not a matter of if, it's when. And then when it does, there's nothing between your eye and the sun anymore. Your eye's the grape, it's gone. That pretty much covers the basics. Got any questions?
So on this telescope, where's the aperture that the light goes into that shows the image?
Okay. The light comes in here.
Yeah.
Bounces off a mirror back in the back.
Like refracts.
Yeah, it reflects. And it gets focused onto actual little mirror right there in front, and it comes out to the eyepiece here.
Okay, so the image comes in from this.
Yeah. Like if I want, of course I can't do
So,
it.
but why is it blocking? Like there's a little tiny. So
That's the second little mirror.
So it would make like a focal point, so you can't see that little black thing coming out.
no, you can. Yeah, once you focus, you can't see that
So, but why is that?
because that's the secondary mirror. That's what actually, when the light gets bounced, that's what actually bounces it up this way.
Oh,
It's just a mirror.
so
sitting
it
on-
hides it using the light.
Yeah, the light bends around it, and you can't see it.
That makes sense.
Any other questions? Has anybody ever? I heard some people saying that. Has anybody ever actually looked through a telescope? Anybody actually got telescopes?
We got the little more expensive Walmart one. No, we probably have a $200 one that somebody bought us. It's really nice. Get really good pictures of the moon. Man, it's awesome with the moon, but far away stuff, it's still
Yeah. I
teeny tiny.
Yeah.
actually,
Not as much as we'd like, but you know, we can't complain.
We're not-
We
Yeah.
see our neighbors if we
but I
want
actually have an ANET telescope
Yeah.
at home, similar to that one, that I do
Photography.
astrophotography on.
the girls for to help them remember.
Here's some examples.
Look, Connor.
Whoa,
That's
That's
just
the
pictures.
Orion Nebula.
pretty awesome. Is that on that?
What a neat topic.
Yeah.
Yeah.